Hello everyone. Welcome to Module 4, Session 2. I'm going to be taking you through the process of accessing and the initial process of image processing using the ArcGIS Pro. So thank you. I'm going to briefly start with a brief presentation just to introduce what we are going to discuss. So I hope you can see my screen. Good. My name is Martin Enyoro. I am a GIS expert under the theme of the forestry ecosystem. So I'm going to be taking you through this session on accessing. It's on Module 4, the GIS for wildlife protection and conservation. So we're going to be going through accessing and processing satellite datasets. But before we begin with accessing and processing these datasets, we need to understand where these datasets come from. So in the previous sessions, we have been taken through what remote sensing is, but just to give a refresher, remote sensing is the science of obtaining information about a particular object or feature without coming physically into contact with it. So remote sensing involves drone data, it involves aerial data. It also involves a lot of analysis. We have to carry out some image classification. And we also need a software for us to carry out this whole image processing. So we have two types of remote sensing. One is where the satellites need a source of energy, which is called passive remote sensing. This is where they use the light from the sun, the naturally available light, so that we are able to, it receives the reflected. I can hear an echo somewhere, but I think. Let me just mute this one. Good, I think we can proceed. I hope my screen is still open. So sorry about that. We can continue. So after the passive remote sensing, we now have active remote sensing. This is where some of the satellites generate their own energy to the target, and it is reflected. It's emitted from the sensing platform towards the target and reflected back. So data collected through remote sensing requires analysis, and most of it, in order for us to obtain information about the object, we need to carry out some analysis so that we're able to generate insights out of it. So in terms of satellite datasets, these are basically the datasets collected from the satellites which orbit the Earth. So we are not going to discuss a lot about drones or drone data or aerial photography data. We're going to be focusing more on satellite data. So that's why I am tailoring my presentation is a bit tailored to satellite data. So this data is collected by sensors on the satellites that are sensitive to specific ranges of the wave spectral bands or wavelengths from the electromagnetic spectrum. And it is also collected at a specific time and from a specific geographic area for particular, in terms of spatio-temporal. This is how often an area is revisited. And then it is also collected at a particular resolution, meaning that a pixel on the image represents a particular area or a particular unit on the ground. So it's mostly represented in terms of meters, and meters to kilometers for the lower resolution. And it is usually also collected at a particular frequency, which is known as the repeat cycle, or when a satellite revisits the same geographical area. So for the satellite instruments, a single satellite can have multiple instruments. And each of these instruments can have multiple sensors, and each of these sensors can detect light in one or more spectral bands. And also, it can have one or more spatial resolutions. An example of this is like the Landsat images that has panchromatic band, which has a different resolution as compared to the other bands. So light is usually light in different spectral bands is usually used to measure different features on the Earth's surface, or even the atmosphere, since different features have different spectral reflectance. And signals from each of the bands usually can be combined to form a variety of images. So we have the natural color, which resembles what we usually see with the human eye, but now we see it as it is from orbit. And then we have the false color images, which show light that cannot be perceived by natural eye. So on the right, you can see what a panchromatic image looks like. A natural color image, I think this is what we all see even on our Google, for example, our Google Earth or Google Maps. And then we have the false color that represents different features are represented differently as what we see in natural color. I have mentioned a bit of resolution, so we have a couple of resolutions, but I'm going to focus on, we have four resolutions, but I'm going to focus on 3. So we have the spatial resolution, which shows the smallest dimension on the Earth's surface that can be detected, which an independent measurement can be made by a sensor. Normally, generally the size is equal to, it should be equal to or larger than the resolution cell. So on the right, you can see what we mean by a high spatial resolution. The image is clearer. We have a medium resolution image there. It's a bit blurry. And then now we have the lower spatial resolution, which is difficult to detect what is particular feature there are. So for spectral resolution, this is the ability of a sensor to distinguish between the different bands of an electromagnetic spectrum. So different features are identified from an image by comparing their responses over the different spectral bands. The panchromatic band, for example, it's just one broad band of the black and white image. We have multispectral bands that are from 4 to about 10 bands. Examples of these satellites is the Landsat and the Sentinel 2. And then we have hyperspectral bands that have different, that have more bands. That have, for example, Hyperion has, I think, about over 100 bands. Then we have the temporal resolution, which is the frequency at which a satellite revisits a particular area. It captures the image of the same area. So some of the freely available satellite data, as you can see from the table, we have Landsat. The provider is USGS or NASA. It has a spatial resolution of 30 meters in terms of the optical sensors, and 15 meter for the panchromatic band. The temporal resolution, when it revisits the the same area is about every 16 days. And in terms of application, there is a land cover change, habitat degradation, deforestation, among very many other applications. We also have Sentinel-2 A and B. The provider is the Copernicus or the European Space Agency. It has a spatial resolution of between 10 to 20 meter optical. The temporal resolution or the revisit time is every 5 days, with applications as the same as landsat. There is vegetation monitoring, agriculture, deforestation. Yes, we have also Sentinel-1, which is a synthetic aperture radar satellite. The provider is also the European Space Agency. It has a resolution of 10 meter. It is a radar image. Temporal resolution is between 6 to 12 days. And this is particularly good in mapping areas that are experiencing floods, forest structure, since we are able to use Sentinel-1 to map even when we have areas that have cloud cover, unlike when we have the optical satellites, which one of its limitations is the cloud cover. Then we have some lower resolution satellites. We have the MODIS and the VIRS, who the provider is also NASA. And the resolution is as indicated. MODIS had a resolution of between 250 meters to 1 kilometer. And VIRS has a resolution of between 375 meters to 750 meters. Their revisit time is almost daily. And their applications is mostly forest cover in case we have forest fires. And when in cases that we have large scale, we want to monitor large scale or a regional scale area. We are also able to detect some night lights using VIRS and also fires. In terms of the importance, before we get to the practical bit of this session, the importance of these satellite datasets in conservation, this has been mentioned in the previous modules, but just to just pass through, one is we are able to monitor habitat and carry out land cover changes. So in cases we have, we are able to detect deforestation, habitat defragmentation. In places that wastelands are undergoing degradation, we are able to monitor this and also monitor encroachment in protected areas. In terms of biodiversity protection, we are able to, satellite datasets are able to support mapping of species distribution and migration corridors by identifying critical habitats of endangered species. We are also able to carry out climate change impact assessment, where we are able to monitor if it's changes in glacier or sea level, as well as vegetation health. In terms of disaster risk reduction in our conservation areas, we are able to track fires, floods, drought, even the reflectance of invasive species as compared to the habitats itself. We are also able to support in policy and decision making because satellite data provides evidence-based information for management and planning. And then in terms of community and resource management, satellite data enables the sustainable land use and planning by showing what the resources that are available and the trends, either going back and the future trends on how it's expected to be. Satellite data is also cost-effective, scalable, and the data we have data that comes oftenly, so it's repeatable data. So the satellites provide consistent and long-term data sets from a local level, regional to a global scale, which this reduces the reliance on some of the effective and some of the expensive and labor-intensive kind of field surveys. So these are just some of the importance on the or other applications, but they are quite more than that. So I would like us to go to some of our live session. So this is how we access some of the data sets. So these are some of the open access portals. So we have the USGS Explorer. This is where we get the Landsat data. Sorry about that. We have the Copernicus Open Access Hub, the Sentinel Hub, where we access the Sentinel data. And then we have Earth data from NASA. This is where now we are able to access the VIRS and the MODIS data. So that's going to be it from my presentation. I am going to stop sharing this. And I would like to share, before we get to accessing the portals, I would like us to move to in our online learning or the e-learning platform. There is, under this session, if you are able to access, I hope you can still see my screen. If you move to module 4, under this session on satellite data, I would like us to download this data so that we can use it practically in our demo. So you click on it, and then you can click on the satellite demo data. Once we have that, it's going to automatically begin the downloads. Kindly, let's start with that procedure as we now see how we access and download these data sets. So the link to access Landsat data is, as I have shown, is earthexplorer.usgs.gov. This is where we access the Landsat data. We have, I would like us to finish with USGS because that is where we are going to access that is what we are going to use today and in the sessions that follow for the assignments. So the first link, this is just an overview. You can visit this link, the links that I have shared on the PPT after the session. So this is just the Earth data platform. So you will require, for the 3 links that I have shared, you will require to register. If you do not have an account, you need to register and create an account. So once you click on the link, on the top right, there is a login. Okay. So I should go back to where we are downloading this data. So on the e-learning platform, we have where we have our different modules. So we are currently on module 4. So once we click on module 4, we have session 2, which we are currently at right now. So down here we have a link or some data sets that we're going to use. It's satellite demo data. Click on it. It gives you the option as we have been doing in the previous session. So click on satellite demo data 2 to open the resource so that you are able to download the data. Save it in a file that in somewhere that you are going to be using, because we are more or less going to be using these data sets even the session that follows tomorrow. I will not download since I already have the data sets. if I click on this link, if you click on the link on Earth data, this has automatically logged me in since I already have an account. But you will need to create an account if you do not have. This is just taking you take you a tour of Earth data and a guide tour of what you learn and how to search on data. You can take a tour at your own time. For now, I'll just skip. So you come and click on login. Okay, it has automatically logged in, but if you do not have an account, you will be prompted to create an account. With this, it's very easy to search for data. You can search data in terms of either the keywords that you're looking at. You can also use, you can also search by a platform, some air-based platform, land-based platforms. You can also search in terms of the instrument if you want raster data, if you want LiDAR data. So we have a lot of data sets uploaded on this platform. You can also search in terms of the organizations. From now, we were talking about NASA, so you can search instruments, instruments based on the particular organization. So that is how it is. You can also search in terms of data formats and all that. So this is just an overview of how to access this to access Earth data. So you can look at it at your own time so that we don't spend a lot of time here. The other platform is accessing the Sentinel datasets. This has also automatically logged me in, so let me just log out. So you ensure that you log in. If you do not have an account, it says that you can create an account for free in 60 seconds, and you'll manage to access these data sets. So I will just log in with my account. So this is how the platform looks like. That is there is a base map there. This is where we have, in terms of these are the base maps. If you want to change the base map to have something different from what is available here. If we want to, search for a particular area, we can, I don't know why, just a minute. So we can, you can create an area of interest on the polygon. This is a polygon. This is you can draw a line. This is, it's hiding some of the tools that are here. So with this, we are able to, just like this, we are able to import a file or an area of interest that you already have. Let me just do that so that we avoid. So we have, okay, the data is still loading. Kindly ensure that you have some good internet so that it's a bit faster. This is just also for your own knowledge. If you want to carry out some image processing using Sentinel data, you're able to access it through this platform. So you can come here and you can either drop or upload your area of interests. So let me just find my data. So I have my area of interest already generated here. I chose an area, a protected area in Uganda. It's called Queen Elizabeth National Park. So you can either upload a zipped shapefile or a KML or KMZ. Let's use the zipped shapefile. So it's still loading. So once you have your area of interest uploaded, we can see, using the base map, you can see we're already in Uganda. We have Lake Edward there and some forest areas. So with this, now if you would like to search for some data sets, you click on the left panel, there is the search tab. There is one that is called Visualize, and on the other side there is a search button. So we can come and search for the different Sentinel datasets that are here. So I would like to just focus on Sentinel-2 and level 2 data. This is the level of cloud cover that we want. This is how we can filter. If you want to filter out images that have a lot of cloud cover, you can do this. Let's keep it at 10%. You can come and select the time range. Maybe we want to check data from January 2024, or let's just use January 2025. To today, or let's use yesterday. You can also filter the months that you want. If you want some of the dry months, the wet months, you can just select the months that you want by unchecking or checking. And then you can just search for your data sets. So this is how you are able to search for what is available here. Let's see if we get something. Good, now we have something. So with this, on your left, we have the different images that are available. So if you just use your mouse, if you move to one of the images, you can see it shows a footprint of the location of that image. So with this, we are able to, we can visualize an image, we can see some of the metadata, and we can use this tab to download the product. So you have to ensure that you download all the data sets that cover your area of interest. So if you come to download, if you click on download, you've chosen that one, it automatically starts downloading. So I'll just cancel since we don't need to use that now. We can also select the particular image that we want. If you want to select multiple images, you can select multiple images of what you want to download. And then you add to workspace. So let me just select a few. Then you can add to workspace. So the products have been added to the workspace. So to access the workspace, To access the workspace, the workspace is right here. We can see we have added 6 products, 6 data sets. Once we click, it opens a new tab. And we can select, these are what we have added. So we can select all. and we can click download to download all the data sets at once instead of downloading one at a time. So you can try this at your free time and try and carry out some image processing from what you get to learn from today's and the next session. So I'm going now to switch to where we are going to access these data sets. So we are going to use USGS Earth Explorer. So I'm going to click the link on the PPT. The same as the rests, you will need to log in. If you do not have an account, you can come here and create an account. It's more or less an easy process. You just put a username and password, confirm your password. Once we have all this information and we have some username requirements and some password requirements, you will get a link through an email. Once you have the link, you more or less just following the steps, and you will manage to access the platform. So I'm just going to log in. If you do not have an account, kindly make sure that you create an account, because you will need to download some data sets for some of the assignments that are coming in through the next session. So I am already logged in. So the platform looks like this. We have the search criteria. We have where we access the data sets, additional criteria, and results. We cannot access the other tabs since we have not selected our area of interest or the date range that we need. So the first thing we are going to do is you can use multiple options to select your area. So we can we have an option of a GeoJSON file, we have a KML file, and we have a shapefile. The shapefile also has to be zipped in order for it to be uploaded in the system. Something you need to note is that the files are limited to one record. That should be one polygon, and should not have should have a maximum of 500 points or vertices. So if we have a feature that has a lot of vertices or that is not more than one polygon, it will not load into the system. So I will choose the shapefile that we selected during when we were searching for the Sentinel data. I'm going to select. I will come here and choose my area of interests. Once it's uploaded successfully, you can just close on this. The reason why my area of interest is just a rectangle is that Queen Elizabeth National Park has a lot of vertices, so I just created a polygon over the area over the protected area, so that I'm able to easily download the data sets. So we have these are the coordinates of our area of interest. If we can select the date range that we want. Myself, I just want image for, let's say, January 2025 to, if we have data from yesterday. In this case, we can also select the months that we want. If you know your particular area usually has some cloud cover. During some months you can unselect, but I'm just going to keep them all. We come to cloud cover, just as in the other platform, we can reduce this to something close to about, let's see if we have something at 15. I think after this, now we can go to search our data sets. So these are the various data sets that are within USGS. So we can select, you can either search, or you can just come here and select what we want. So we want to download Landsat data. So Landsat, we have various collections of Landsat data. We have Landsat collection 2 DEM. We have Landsat atmospheric auxiliary data. We have collection 2, Landsat collection 2 level 1, which has not undergone some atmospheric corrections. So we are interested with the data that has already undergone some atmospheric corrections. So I will select, since our search period is between this year, we do not have Landsat 4, 5 this time, so we will just select Landsat 8 or 9, whatever is available. And we can see now the other tabs have been activated. So we can click on additional criteria if we need to add any additional criteria. If there is anything we would like to add, if it's in terms of the path or row or the particular satellite, or this is just like a filtering mechanism. I'll just leave it as it is, and then I'll just go to results so that we see what we have. We have some data sets. So, okay, I'll go back a bit. I'll just go back a bit to let me begin again on our search criteria. As I mentioned, we can search through a GeoJSON file, a KML file, or a zipped shape file. And something that is important to note is that it should be one polygon or a line string, and should have a maximum of 500 points. If your area of interest has more than 500 points, the system will not pick it. It will bring an error. So you have to, if it is an area that is irregular and has a lot of polygons, you can just create a shapefile just over your area. Yes, so in this case I had created, my area is Queen Elizabeth National Park. It is quite, it has a lot of vertices. So I just created this area of interest just over the protected area. To select the file, you just come and select the file. I can just, so that this was my area of interest, let me just try and upload it so that you can see. Yes, you see, please limit your shapefile to one polygon or polyline. It had multiple features, so that is why it's refused to load. So we come and select our area. I have chosen this. We have it there. With this, now we come to the date range. What period are we studying this protected area? For my study, I have chosen any image between this year from 1st of January to yesterday. If you want a particular month, maybe you just want images collected between January, February, and March, you can select that just to limit the number of results that you get. But in my case, I'll just select all. Once we have this, we can come to the cloud cover that we want. We can minimize as well the cloud cover so that we don't have a lot of images that have 100% cloud cover. So we can filter and have it at 15% cloud cover. With that, we can go and search for now our data sets. So in the data sets that we have under the USGS platform, we have quite a number of data sets from some of the aerial data sets that are uploaded here. Some of them are not within the African region. We also have UAS data. We have some radar data as well. But we are interested in Landsat data. So in Landsat data, we have data sets. We have the Landsat legacy data sets. These are mosaics from a bit earlier. We have some DEM data sets as well. Then we have collection 2 atmospheric auxiliary data, where we are not interested in that. I want us to focus on these two, the Landsat collection level 1 and 2. So level 1 data it's just the raw data that has not undergone atmospheric corrections. But the collection 2 has undergone atmospheric correction. So this is the data that we want. So since we are just going to download the data and begin our image processing or analysis, so we'll select Landsat 8 and 9 because of our date range. And then after this, we have the additional criteria tab. This is also, we have already set our data sets. If we want to limit, if you know the path or the row of your particular image, if it's a certain satellite that you need, it's either between 8 or 9, you can also filter out just to have exactly what you're in need of. And then we can now go to what we have, or our results. So with this, we can see what we have. So we have a Landsat 9 image. These are the path and rows that was collected on 31st of July 2025. So this image, in order to know, yes, we have searched for our area of interest, but what part of our area of interest does it cover? So we can use the footprint so that we're able to see the coverage of our area. So this is one, so we can see it covers part of it. We can also have an overlay of how the image looks like. This normally takes some time. Yeah, we can see our image is good with low cloud cover. We can also compare browsers, but we can also select our metadata. We can click on metadata to see how our image looks like. We can see that, for example, the land cloud cover is at 0.79, which is quite good. We can see, when I was talking about the path and rows, this is what I'm talking about. You can also search a particular scene using this, the path and rows. Yeah, and the time the product was generated, and the level 1 was created, and level 2 was generated. So with this, we can select the images that cover our areas. So we can just select some of the images that cover our area of interests. We have full coverage of our area. So we have images. This was on 30th of July, another one on 30th. Yes, so with that, we are ready to download. So we can come one by one. You click on the download. There is an arrow with a disk sign there, gives you the download options. And then we have where we have add to bulk to download. So I'll come and select this. So we have some various options. We can add all files to bulk, down all files. This is, I usually come to this option of product options, and then I download the whole product bundle. So I click on download. So once you click on that, it opens up a new tab. So another option is using the add to bulk option, so that you're able to download your files as a bulk. So I have a bit of yes, it's not yet started downloading, but I just wanted to show you how it, yeah. So that is how it comes. That is how it shows up. This is a file type. It's a zipped file with the description of the data sets that we are downloading. So since we already have our demo data, you can use this at your own time to download an image of a protected area in your country, so that we are able to use that from what we learned today. But for today, I hope the data that you downloaded from the e-learning platform has already finished downloading, because I would like us to now get into the arcgis part of it, where we now begin to load and understand how our landsat data looks like. So I'm going to stop sharing this. So I'll come and open my ArcGIS Pro. So we are here on, we go and open our ArcGIS Pro. We click on a new project. We can, I would like us to save our project somewhere. So I'll just create a folder here. I'll just call it Queen National Park. And I'll save my project as I'll save it as that. So I click OK. So we have our Pro. So we can now add our data sets. So first thing, we need to go to where our data sets are. So the imagery, this is what we have. It comes as a zipped folder. So we can I'll just right click on all of them. Select all, I'll right click, and I'll come and extract each archive to its own folder. So the data sets that we have are all downloaded, are all captured in August 30th to 31st. Sorry, not August, July. So we come and browse to our folder. We come to where we have put our imagery. I will begin with the first file. We have a number of bands. So we just come and select from band 1. I'll select up to band 7. You select all of them. Then you click OK. Okay, so this is how it looks like once we have our we have uploaded our data sets. So I'll also come and for you to appreciate, I'll just come and load. I'll also extract the shape files, our AOI. So I'll select the area that I used to, the areas that I used to search for the data sets and the exact area, our area of interests. So I come to my AOI, I can refresh this, come and select this. And I can come and select the other one. So this is what I used. So my area, this is my area of interests, what you can see in orange, but the green shapefile is what I used to download the data sets. So let's add, you can see that the data sets don't cover the whole area of interest, so I'll load another image. I'll load the third image, band 1 to band 7. Okay, this doesn't seem to cover the whole area. Well, since I can see that this doesn't cover the whole area, we'll just use one for demo purposes. Let me just unload all of them and we use one for So let me just use one image. Let me unload all of these. Let me just remove them all. Let's just use one image and we'll create our own area of interest. I've seen the imagery doesn't cover all the data, doesn't cover the area of interests. So we just come to Imagery, just select this, select our bands. So we have our different bands from band 1. You can see it's band 1 to band 7. The first thing we need to do is to create to layer stack all these images to form one image or create an image composite. So the first thing we need to do, we need to arrange them from band 1 to band 7. Just kind of arrange them in order. So we can see we have 7 images. So in order for us to just have one composite image, there are 2 ways we can do this. There is the easy way. So we can select our bands, the 7 bands. We select them as they are. We come to the imagery option. Before we select this, let me just show you something that happens here. We can see if the images are not selected, some of the tabs are not active. If we select one of the images, some of the tabs are now active. So we select our images. We can create our composite band in 2 ways. We can just, once we are on the imagery tab, we can come, there is a tool for process. We can now just come and create a composite. That is the easy option, so it combines all the 7 into one image. Option 2, we can come to analysis. We can come to our toolbox. We can come and search composite. So we can create a single raster datasets from multiple bands. So we click on this, and then now we select our bands in order from band 1, band 2, and band 7. So we don't need the last one. So we have our bands in order, and then this is just the output composite band. With this now you can just run. It will just also combine all the images into one data set. So this normally takes some time, so let's just use, so we can close this. So we have so these are just the same. They have just been layer stacked in different ways. So we don't need the different bands that we had. So we can remove. The data sets. So we can just use one of these. So let me just remove one. So with this, there is a way that we are able to carry out our symbology to better see how our image looks. We have combined all these data sets into 7 bands. So we can see them here. The first thing we need to see is how our image looks, as I had mentioned in the presentation, how the imagery looks in natural color. So the band combination of this is different. So we can see in what is being displayed, red is band 1, green is band 2, and blue is band 3. But how the landsat bands are set up Band 1 is usually coastal blue. It's coastal, so for red is usually band 4, sorry. Red is band 4, so we select band 4. Green is band 3. And blue is band 2. So this is how, if we zoom into our image, this is how we are able to see how our area looks like. So we can see we have a bit of some forests. We have some agricultural areas around here. We also can see some forest. We have some urban settlements around here. Yeah, so we have a big, I think this is a kind of a mountainous area around here somewhere. We have some water bodies. So this is just what you can see over just in natural color. But then there is what we cannot see when we use the near infrared band. So kindly also make sure that you save your project in case you want to avoid doing the whole process again. So we can right click again on our composite, we go to symbology, so that we are able now to view our image in false color. This is now what is natural color, but now we want to use the near infrared, which features reflect differently using this band. The false color combination is near infrared is band 5 for Landsat. So I'll come and select red as band 5, green as band 4, and blue as band 3. So now this is how you're able to also interpret this image in a different way. So we can see, from what you can see, what was represented as green is now red. We had seen water bodies had a different color, but we can see that the reflectance value is close to black. We can also see that this is how you're able to interpret where the water bodies are. We can see some water bodies around here. This, from what we can see, this is an urban settlement. This is more or less like a town that is here. We can also see some of the areas we were seeing as agricultural farms have different, show differently on the image. So I would like to also, we can come to map. Once we are on a map, we change our base map to something like like an image or an image hybrid. Let me just select image. With this now we are able to compare from what is in false color, our composite image, and from what is on our base map. Base map now shows what is in natural color, and also in a bit of a higher resolution as compared to our Landsat datasets. So if we compare the two, we can see there is a bit of agricultural activity happening around here. If we compare it with our composite, we can see that it's quite distinct, that we can see some agricultural activities happening here. If we compare what we have on our composite and what is on our base map, you can see this is a lot of settlement area. I think my internet is, we have some agricultural lands here and a bit of settlements around here. You can see there is a setup of a town there. If we compare with this, you can see the reflectance value is different. So vegetation reflects differently on the near infrared band as compared to urban settlements, water bodies, bare land, agricultural land, all that. Yeah, so with our image composite, we had an area that, let's say we have our area of interest that we need to clip out, different, just so that we don't process the whole imagery, we need to clip out our our area of interest. So we can create a new shapefile. We can come to our folder. Where we have our demo. So we come to our demo and create. In our area of interest, you right click on it. We come and create a new. We can come and select a new shapefile. So I'll just call it, this is a location. I'll just call it new AOI. The geometry type, we usually have either the point, polygon, or polyline. So I'll just select the polygon. We don't need the template datasets. If we need to have a coordinate system, I'll select the composite, so it can use the same coordinate system to avoid a lot of reprojection. So we have our shapefile created here. So I'll just we can come now and create our area of interest. So I'll just draw a random area so that I can show you how to clip out the area of interest that you're interested in. So we have this. Once we're on the edit, we make sure that we save so that it is saved into what we have created. If we open the attribute table, you can see we have one feature under our shapefile. So I can close this. I can also close the attribute table. So we have what we want so that we are able to clip out. We don't need to process the whole imagery. We just need to process within our area of interest. So with this, we come again to our imagery. On the raster functions, there's a drop down. You click on raster functions. You can search here, or we can come to analysis, come to our geoprocessing tools, and we can search. We need to extract by mask. So this is extracting cells of a raster that correspond to a defined area. So we we extract by mask. So the first thing is the input raster that we want to clip out, to extract. And then the input feature that we are going to use to clip out. And so this is what the output layer will be. And then we have the extraction area. We have either inside, these are cells within the input, and then we have on the outside where we select what is on the outside. So after this, there is no much to do here. You just run. Composite. kitu inatoka. Just a moment, get to understand what is happening here. It contains spaces. Let me figure out what is happening here for one moment. Apologies for that. We had some technical issues that I was trying to sort. So there was an error that was here due to, when we have an X, it indicates the error. And from what I have found out is that you can see that the error is saying that the input path contains spaces. This is due to the fact that where I had saved my folders, my dataset had some spaces. So let me just, in my folder, you see all the spaces within the folders. This is what is bringing the error. So I have created a new folder, and I have saved our new composite in that folder, and I have also created, saved my area of interest into this new folder that does not have any spaces. So our data sets are there. So for us to continue to extract, to export, so we do not have an error at the moment, so we can just run. So with that, now we have our clipped area, or our exported area. There is also another option where we can right-click on an easy option. We can right-click as well on our image. On data, we export our raster. When exporting, we just select, we select our output path and our output format, and then we can use, this is where we can use our, no, not this. We can use our area of interest to clip the images. So this is an easier option and a faster option, but it's good to get to know both options. So with this, we are able to export our image to the path, to the default path. Yeah. So we can export our image, but there is no need since we already have our area already cropped. So this is what we have. With this now we are able to process our data sets a bit faster. Let me just go back to our band combination. the false color combination. So with this, we can also work on how our image looks like. We have different display values. So we have minimum to maximum. The default one is cutoff percentage of the highest and lowest values. And we still have some others depending on how we like to display our image. So I'll just stick to our default setting. So now with this image, we are able now to start our image processing. We can generate some indices from these data sets. And if you have multiple images and you would like to mosaic them, like let me just use the two that are on display at the moment. If we would like to mosaic or bring two images to have one to be exported as one image, the same thing is we go to our raster options. Under the system tab, we can either search, we can mosaic rasters. So it's stitching. This is to stitch and stitch a set of raster data sets together into one data sets. So we can come and select the data sets that we want to mosaic. This is also pretty easy. The operation is on blend. Then we can, option is to create a new layer, or you can also save as a new layer. So if I create a new layer, it now mosaics two images into one output image. I know it doesn't show much of a difference because it's still the same image, but that is how you mosaic the two images together. So from what we have, I can show you how to create an ndvi. To create ndvi, so I would like to ndvi is usually calculated using the near infrared band and the red band. So plants absorb different reflectance. So this is how we are now able to know the healthy parts of our vegetation, the healthy parts of our forests, our large farms. So to do this, we have to select the image that we want to generate ndvi on. So not what we have mosaiced, but what we have extracted. This is it. You select on it. We come to the raster functions. We can either search as ndvi, or under system, it's usually the first under analysis. Under analysis, we have ndvi here. So for us to generate our ndvi, we select the raster data sets that we want to use. Then we select, I have mentioned that it is usually a calculation of near infrared and the red band. So Our near infrared, this is the visible band, which is band number 4, and our near infrared band is band number 5. So we click on the scientific output so that we are able to have the values how they are usually represented. So the results of ndvi range either between 1 and -1. So where higher values indicate the denser or healthier vegetation, and the lower values indicate non-vegetated areas, bare soils, could be snow or water bodies. So with this, we can now, it's a raster layer. Then we can create a new layer. So this is what we have. Our ndvi values are between 0.5 and between -0.05, where the lower values now indicate areas that are non-vegetative. So I can come here to symbology and change the color scheme. Select one, let me select this. So we can either have them as that. So depending on how you want to view them, in our image we can see the areas that are the areas that are green or a bit of orange show areas that have low ndvi values, and in most cases they are either water bodies or areas that do not have vegetation. We can use our base map as a reference to see how true our data is. Let me uncheck this. So within our small area here, we have some grassland or some areas that have a bit of settlement, and if we check our ndvi values, we can see that they are we have some low ndvi values around here. So it means that we have some, you can see this is now, we have a town here. You can see that is why the values are on the negatives. For the areas that have higher values, like on these mountainous areas, we can see that the value of the ndvi is, we can see that it is well represented on the map when we compare it with our base map. For areas that have some water bodies, and to see, this is like a mountainous area, so we can see that the value in here is quite low. So in this part we do not have much of vegetation. Same as this, some of these are already water bodies. This is a water body, hence the lower ndvi values. With that, now I would like to stop there, and again apologies for the bit of challenges with this. We are going to learn a bit more on some of the image processing skills, on how to create land use, to carry out land use, land cover change, and how to use this data in monitoring our habitats. So I'd like to stop there. So I can stop sharing. So maybe we can have a few questions before we end today's session. So we can maybe start with Raymond. Raymond Mwalili. Raymond, you can unmute yourself.
Good morning.
Good morning, Raymond.
Thank you for the session. It was really amazing. Although kuna some parts zenye tumechwa nyuma, but we'll catch up.
Okay.
I wanted to raise concern with module 3, session 5, but I see it has been sorted out. Thank you.
Okay. Thank you for that. We can have Ibrahim Ambale. Ibrahim, you can... Yes, Ibrahim.
Hello, Martin.
I'm well, I can hear you.
Yeah, I'm also well. Thank you for the great session. At least I know what remote sensing is and how it's being done.
Yeah.
And my question would be, the other sites that you have just shown us, like USGS, are these sites free? Because I've tried to register, but I cannot be able to access the data. What I can only see is details of my profile, but I don't know where to click and access the data. So maybe if you could just show us again on that. Thank you.
Thank you, Ibrahim, for that. Let me just share my screen one more time. Just a moment. Make it in the phone. Just okay. So if you have already, once you log in, once you are able to create your account, let me just once you've through the process, they will send you a link. I think I have that kind of a link somewhere. Once you create an account, Ibrahim, you should just try clicking on the link that I have shared, on this particular link, and you will manage to access, because this directly, yes, once you have created an account, it always gives you the option first of updating your profile. So if you have a challenge, once you have updated your profile and it's you're not able to access where you get the data sets, just click on this link. This link that takes you directly to where we are going to access the data sets. You just need to sign in. With this, you have minimal challenges. It takes you automatically to where we are going to search for our data sets. So you can just try it before the session is over, and you can let me know if you're able to access.
Okay, thank you so much, Martin.
Okay. So we can have Pascal. Pascal Muller. Kindly unmute yourself and ask the question. Pascal? Maybe before Pascal, we can have Teddy. Yes, Teddy, you can unmute yourself.
Good morning, Mr. Martin.
Good morning, Teddy. How are you?
I'm very fine.
Yes.
Thank you for the presentation.
Okay.
I would like to ask, maybe can we access the data, this satellite data? Can it be downloaded from Google Earth Engine?
Yes, it can be downloaded through Google Earth Engine, but from what I understand is that Google Earth Engine now these days has a bit more of, it's turning to be a bit more commercial, so that could be a challenge. I'm not sure at the moment, but I have been informed that there is a bit of a challenge on Google Earth Engine at the moment in downloading the data, but it is accessible on GE. You can also generate these products directly through Google Earth Engine.
Okay, thank you.
You're welcome, Teddy. We can have Cecilia. Cecilia, kindly unmute.
Thank you very much for your interactive session. I just wanted to ask, when will the online learning platform be still active after the live session are done, because I'm still a little bit behind.
I think the platform will be active throughout the sessions, even after the live sessions are done, even if you're a bit behind. I don't know when the cutoff deadline is. Could be next week, end of next week. So you still have some time so that you're able to cover some of the contents that are you have not managed to finalize.
Okay.
Okay.
All right. Thank you.
You're welcome. So Simon Tembo, kindly go.
Yeah. Thank you, Martin. I had a problem, maybe if you can repeat, especially on the selection of the area of interest to when to download the data in the available platforms which you shared. For example, the one which you are sharing, can you maybe come again on how you can create an area of interest so that we're able to download the needed datasets? Thank you.
Okay. Thank you, Simon, for that. So I'll so to download this, to download your datasets, by default it takes you somewhere in the US. It takes you somewhere in the US. So the platform looks like this. Under the search criteria, this is where we select our area of interest. This is also where we select our date range. So you can come to the GeoJSON/KML/shapefile upload tab. If your area of interest is in a GeoJSON or a KML or a shapefile, you just select which is which. If you select GeoJSON and it's not a GeoJSON, it will not upload. So I was using a shapefile. So I come to the location of my area of interest, and I just select it. So once it is there, you can close the tab. What I was indicating is that this is critical because it has to be one polygon. It can be, a shapefile can have multiple polygons, so it has to have one polygon or a line string and have a maximum of points. The points I'm talking about are these vertices. If they are more than 500, it will not upload into the system. So in some areas, in some instances, you might not have an area of interest. Maybe you want just to map out, let's say, Kigali city. So if it's in Kigali city and you don't want to create an area of interest, you can just use, and where we are selecting the polygon circle predefined area, we can come and use the map. Once you click on use the map, it automatically covers the area that the map was viewing. So now you can come and minimize the area to maybe your particular area of interest. So this is also another option of if we just wanted Kigali city by itself, we can now just select to a smaller area of interest. Let's say something like that. Just put it as a regular polygon, something like that. If now we have this, we can now come and select our date range. Let's say you just want imagery that was covered from June, 1st of June to yesterday. So if we have already selected the months that we are in, so we can also now minimize the cloud cover to reduce the number of clouded images that are there. So let's just maybe use 20%. Then you click on the datasets, where we now select the datasets that we need. We said that we are going to work with landsat collection 2 images, and we select landsat 8. You can still select the rest. Oops. We can still select the rest, but there is a warning on the Landsat 7. So we don't, let's just stick to Landsat 8. After that, this is the additional criteria is where we were talking about if we want to filter, because what we have filtered on, we had filtered on the month and on the date range, month, and the cloud cover. So as I had shown previously, if we want to minimize on the rows and the paths and rows, we can use these to select the particular rows and paths that you want. After that, we just check on what results that we are getting. So that is how we search for datasets in the USGS platform. I hope that is okay.
Very much, Martin. Thank you.
Thank you. So one last question from Karen. Karen, you can unmute yourself.
Hi, can you just take us further from where you've just left off? So how do you download those data sets and get them into ArcGIS?
All right. So from where we are at now, we can see at least one of the images covers our area, but I can see if we have another that covers it a bit better than not on the edges. Seems like most of them cover. Okay, let me just use, I've seen one that is here. Let me use this as the option that we are going to download. So if we need this image, so we can, this is the footprint. Footprint now shows the extent or the size of that image. And now it shows on how it covers our area of interest. We can also have like an image overview of how our image looks like, so that we can see if our area has some cloud cover. But from this, the image is good with low cloud cover. We can also check on our metadata, the metadata of the image that shows the product, the date the image was acquired. We have the paths, the paths and rows, the start time, as well as other information such as cloud cover and all that. If this image looks good to us, since it's just one image, there is a disk with an arrow which gives you the download options. With this, we have add all files to bulk, download all files now, or we can select the files. I prefer coming to the product options here, and where we have this product bundle, this is where now you use to download the entire bundle of all the bands of the images as one file. So I just click on this. It opens up a new tab. I think this is mostly dependent on your internet speed, but with this you're good to go. Just pops up and gives you an option of saving where, saving the file to your preferred location. So this is the pop-up. This is a pop-up, so we can now download to the particular location that we need. So that is more or less how we are able to download datasets from the USGS platform. I hope that is okay. All right, just something before we close today's session. I can also show you how to go about it. Under session, for tomorrow's session, on the e-learning platform, we have some datasets that you need to download a bit well before the session begins. So the data includes some area of interest. We have the MAU area already layer stacked. And then we are going to have some image from Landsat image from 1995 and another from this year in 2025. So this is going to be used from tomorrow's session. So kindly make sure that you have downloaded these datasets in advance. So that is it from me. Thank you for your time, and see you tomorrow. Thank you.